Let's continue to investigate the meaning of the slope and y-intercept values on a linear model and within the equations for the linear models. Here we have 4 examples of 4 situations with scatter plots of data and then also a linear model drawn in for the graph and an equation of that linear model also being shown. A says, using the horizontal axis for x and the vertical axis for y, interpret the slope of each linear model in the equations shown in the scatter plots. All right, let's start off with A. So in A, the slope, y equals mx plus b, the slope is negative 9.25. And so once again, let's just think about what that means. On the x-axis, we have age in years, and on the y-axis, we have reaction time. So remember slope, what we were talking about on the previous page, basically means for every 1 we go over this way, what is happening to the y? In this case, the y values are going down by 9.25. So that is the meaning of the slope. Every time we go over 1 on the x-axis, what's happening to the y value? And so every time we go over 1 year, so every time the age increases by 1 year, the reaction time goes down by 9.25 milliseconds. All right, so let's write that down. Now let's go with A here. So for every 1 year of age, reaction time decreases by, is it 9.25, I think? Yeah. So decreases is where that negative comes in. So decreases by 9.25. And at first I thought it was seconds, but it's actually milliseconds. So let's write that down, milliseconds. So that's the meaning of the slope for A. All right, let's look at B. Here is our slope in B. And again, every time we go over 1, the slope is telling us what's happening to the y value. So in this case, we are increasing by 0.44. So what's on our x-axis? Bananas. So every time we have 1 more banana, the price increases in dollars. So that would be what, 44 cents. For every 1 banana, the price increases. It's price, right? Do we say, yeah, price in dollars. So price increases by 44 cents. So $0.44, 44 cents. All right, let's look at C. All right, slope in C is 4. So again, that means every time we go over 1, that means that our y value is increasing by 4. So every time we increase the room size by 1 square foot, the cost of installing the flooring increases by $4. For every 1 square foot in room size, the cost of flooring increases by $4. Another way of saying that maybe is that the price of flooring is $4 per square foot. That might be a simple way of thinking about that. So if you went in to like Home Depot or Lowe's and you were doing some flooring and you were estimating the cost, this flooring looks to cost $4 per square foot, which is really a slope, if we're thinking about that. And finally, D. All right, D, we have negative 2.4. So notice this time our line is going down And just like before, so every time we go over 1, in this case, the y values are going down by 2.4, so negative 2.4. They're going down by 2.4. So on the x, for every 1 degree in temperature increase, the volume, whatever we're measuring here, decreases by 2.4 cubic centimeters. So for every 1 degree increase in temperature, the volume decreases by 2.4, in this case, cubic centimeters is the unit. Okay, so hopefully you're kind of getting used to how we think about that and the meaning of the slope. It's the change in y for every 1x, and then we can kind of put that into the context situation. All right, let's do the same thing now for if the linear relationship continues to hold for each of these situations, interpret the y-intercept of each linear model in the situations provided. All right, let's go back up to that first one. Now notice that the linear models really don't have a y-intercept that's easily shown. Like you could try to trace this back as long as you get to 0, and you could kind of come up with an estimate of it. But the y-intercept is shown in the equation, so we know that that actually is going to be 400. All right, so what does that mean? Well, 400 would be if you had a 0. So the coordinates, let's just think about that for a sec. So the coordinates of y-intercept will be 0 comma something. So in this case, 0, 400. And so the x value is 0. So that means at age 0, the reaction time is 400 milliseconds. Okay, so that's literally what that would mean in the context of this situation. For an age of 0, the reaction time is 400 milliseconds. I'm going to put LOL in parentheses here because so this is one of those situations where the linear model starts to make sense when you get into, the ages here. It looks like about age 8 or so is when the linear model kind of starts accumulating some data. But if you trace it backwards, so this is again called extrapolating the data. When you extrapolate beyond the points that we have here that generally run from roughly age 8 up to age 22 or so, anything outside of that you're estimating is called extrapolating the data because you're estimating beyond the data set that you have. So at age 0, does it really make sense to have an age 0? So a 0-year-old has a very long reaction time when you're 0. So it doesn't really make a lot of sense in the context here. So this is one of those situations where it only starts to make sense kind of in the middle of the graph, the middle of the scatter plot for estimating. So we always have to use our brains a little bit when we're thinking about interpreting these numbers. Okay, let's take a look at B. So in this case, the y-intercept again, if you trace this backwards, it looks like it's pretty close to 0, so it's not exactly right at 0 here. It's 0, 0.04. So our y-intercept is 0.04. So for 0 bananas then, the price is 4 cents. That's literally what that would mean. For 0 bananas, the price is 4 cents. I'm just going to write next to this. So I suppose there could be some startup costs that we're thinking about, like when you're charging for food, maybe there is some packaging costs or something like that you'll build in, so your price doesn't actually start at 0 for 0 bananas. It'll actually start at a little higher level. But obviously 0 bananas aren't going to cost anything because you haven't bought anything. But in terms of the linear model, if you extrapolate it all the way back to 0, then that literally what would make sense. So once again, this this data is probably going to really only make sense from starting at 1 banana and probably can continue on beyond that. It'll probably continue to make sense beyond that, but it doesn't really make as much sense for the y-intercept. So you have to just kind of consider that when you're using this as an estimation. All right, C. So if we extrapolate this backwards, looks like it's going to cross down here. Okay, so it actually turns out 87 is where it's going to cross. So 0, 87. So that would mean for a room that is 0 square feet, it's going to cost $87. Okay. For 0 square feet, the flooring will cost $87. Okay, so once again, maybe that's like a startup cost. So if you're having the flooring installed, maybe the installer says, okay, well, I'm going to come to your house and it's going to cost $87 for me to show up, and then it'll cost $4 per square foot. So maybe that's what it is. But if you're literally just buying the flooring, if that's what this really means, then 0 square feet isn't going to cost you money because you haven't purchased anything. But sometimes when you are actually having it installed, when someone comes in to install it, they are going to charge you an amount just to come out to your house or to your place that you live, and then they'll charge you a certain amount of money to actually do the installing. So it could mean that. So there may be an interpretation there that makes sense. All right, D. Extrapolating this backwards turns out to be about 25. So 0, 25 would be our y-intercept value. So for 0 degrees temperature, the volume is 25 cubic centimeters. For 0 degrees temperature in Celsius, the volume is 25 cubic centimeters. Now this could make sense because you can definitely have 0 degrees Celsius. All right, that's definitely, in fact, that's 32 degrees Fahrenheit, right? 0 degrees Celsius is the freezing point of water, and in Fahrenheit, that's 32 degrees. So you definitely could have a volume of whatever we're measuring here. We're not quite sure what's being measured. We're not told that. But the volume could be continue to go backwards, and it could actually be even into the negative temperatures, right? So this one could actually be maybe pretty accurate as you extrapolate backwards beyond the data set that we have. And notice the data set runs from roughly 1 degree, 1.5 degrees up to 4.5 degrees. So, but the literal meaning of the y-intercept is